それではですね、略解のビデオになります。で、略解のビデオでも課題があるんだったですね。で、課題はいつも同じですね、決まっていたということで、簡単に説明しておきます。もう知っているとは思います。1番目として略解を見て試験の自己採点を行ってください。で、2番目として自己採点でできたところできなかったところを区別するということですね。3番目として、これがまず重要なんですけども、できなかったところは何が原因で、何が原因というのはどんな勉強方法でできなかったのかを自己分析するということです。できたところはどんな勉強方法が原因でできたのかをやはり同じように自己分析するということです。全て丸だったという場合はできたところの自己分析を行えばいいということですね。で、この自己分析をすることによって自分しかわからないわけですけども、これがっていう気づきがあるわけです。どういうこういうことがあったからよくできたんだ、こういうことができなかったからできなかったということが分かるんですね。これをですね、課題としては、自己分析した内容を記載してそれを課題として提出するということです。で、この内容はですね、次回の試験までに繰り返して自己分析による勉強法の改善とするということですが、この科目については、後期があるのか後期がありますので、その場合は自己分析によって勉強方法が改善できますし、それから他の科目にも、適用できますので、勉強方法ですからね。なのでこれを自己分析した内容を振り返るという意味があります。ではですね、早速ですね、問題を見て、そしてそれから略解ですね、brief answer を見ます。1番ですね。As illustrated below, 3 6.0 kg masses are joined together with approximately and massless. approximately と書いているのはですね、if it is exactly massless, that means m equals to 0. So nothing means it is not a matter. It is not a real thing. Nothing empty. So it is nonsense. So it means so approximately. So 大体というのは本当に0だったら何もないわけですから、そんなことはないので、だから大体と書いてます。要するに、compared to the three masses, it seems to zero. そう、比較する対象がですね、6kg の質量、これに比較すれば massless ということですね。approximately massless loads っていうのは、これが棒ですね。jointed くっついてる、棒、6kg の質量と質量をつないでいる棒ということですね。So it means the approximately massless loads in the shape of an equilateral triangle with an edge length of L equals to 4.0 meter. It is the shape of the mass and the load is triangle, and the shape is exactly equilateral triangle. Exactly ですね。全くその equilateral triangle というのは正三角形ですね。Every edge length of the shape of the triangle is the same. L ですね。全部 L ですね。で、L の長さですけども、the length of L equals to 4.0 meter. 4.0 メートルですね。The 6.0 kg masses are small in size compared to the length of the rod. 今度は、大きさのことを言っています。It means the masses is point-like object. So it can treat as point-like object. That is the meaning. the 6.0 kilogram masses are small. It means it can treat as point-like object. Small in size サイズとして小さいから、point-like object で扱っていいわけです。Compared もちろんさっきと同じですね。質量が nothing と言っているのは何と比較してですね。ロッドの重さと、masses の比較しています。今度のサイズの比較もですね。Compared to the length of the rod。ロッドの長さに比較してサイズが小さいので、だからpoint-like object に扱っていいよ。こういう意味ですね。はい、ここまで分かったので、あとは解けばいいですね。問題。Determine the moment of inertia of the system about the y-axis. Y 軸周りの慣性モーメント。The moment of inertia を切ります。The moment of inertia is mass times r squared. R is the length of the length of the point to the masses. The point is the shortest length of the rod from the rod, the rolling rod. So in this case, I will show you y-axis is the rotation axis, and the length is, for example, this mass is that here, this length is, and that mass, for that mass is L is the length, and that case it is on the y-axis, so the length is 0. So in this case the length is 0. 6 is the mass, 6.0 kilogram masses, and the length 0 in that case. And this one has a length of 4. It means 6 times 4 square. And in this case, here, it is half of 4 because it is middle of these two masses. It is located as here. So this length and that length is the same. So the length, this is equals to here, this length. It means 4 divided by 2 meters. So moment of inertia I equals to 6 times 0 square plus 6 times 2 square plus 6 times 4 square. It is a value of 120. So the answer is 120 kilogram meter square. 120 kilogram メートル以上という答えですね。よろしいですね。で、2番目いきます。Three bananas are joined together with approximately massless rods. The bananas are small in size compared to the length of the rods. This is the same as the former questions. We cannot think about the masses are the xy coordinates of the bananas are listed below. A 400-gram banana has a coordinates 3.0 meter 0. 300 bananas has coordinates 0 2.0 meter. A 500-gram banana has coordinates minus 4.0 meter, 1.0 meter. The question is, determine the moment of inertia of the system about the z-axis. About z-axis. So, it means the length is r. R is equals to x squared plus y squared. It is the value of r squared. It is a Pythagorean theorem. It is as Pythagorean theorem. So r equals to x squared plus y squared. Square root of x squared plus y squared. Here, this equation. And that is r. So, point banana can think as a point because it in size it compared to the length of the banana are small in size compared to the rod. So, banana has a coordinates tam-tam, so we can easily calculate r as here 3 square plus 0 square. Square root of 3 square plus 0 square. It is 3.0 meter. It is r1. So the mass is 0.4 kilogram times this r1 square. And the second one is also, the third one is also the same consideration. So m2r is 0.3 kilogram, r2 equals to 2.0 meter, m3 equals to 0.5 kilogram, r3 equals to square root of 17 meter. So we can easily calculate to add these three masses of the moment of inertia. So it is 13.3 kilogram meter square. The answer is 30.3 kilogram meter square. It is a value of the moment of inertia of the system about the axis. 13.3 キログラムメートル以上です。次ですね。Derive an equation for the moment of inertia of a solid uniform disk lying in the xy plane and centered about the origin, about the y-axis in terms of its radius r and total mass m. Uniform disk, solid uniform disk is the point. So I equals to integration of r perpendicular square dm. Here it is written, dm is written here, and about the y-axis. So here it is y-axis, and the length is here r. That one. So dm equals to sigma dA. So I equals to sigma integrate r perpendicular square dA. dA is r d theta dr. So we can rewrite the value of I as this equation. dA equals to r dr d theta. Here are perpendicular square. So integration is the lower limit is definite integrand for r. The lower limit is r equals 0. And the upper limit is r. For the theta, lower limit is 0 and the upper limit is 2 pi. So we can calculate these. And we have here, okay. Here I equals to pi sigma r to the fourth divided by 4. Here. Okay. Yes. And the equation said in terms of its radius and masses. So we must know the relation between sigma and m. The relation between m and sigma can have calculated this. As calculated this, we can have the relation m and sigma. M equals to integration of dm. So 2 pi sigma times r squared divided by 2 minus 0 squared divided by 0. So it is m. It means m equals to pi sigma r squared. So we can easily change the equation of the sigma. Sigma equals to m divided by pi r squared. By inserting this sigma into this this equation here. So we have the final result I equals to mr squared divided by 4. It is the answer. はい。なので、I イコール余分の mr の事象というのが最終答えになります。Number 4. They leave an equation for the moment of inertia of a solid sphere with non-uniform density rho equals to beta r, where beta is a positive constant about an axis that passes through its center in terms of its radius r and total mass m. It is also similar questions as the formula. 同じような問題ですね。I equals to integration of r perpendicular square dm. So we calculate as here. So we need to use here dv. dv equals to r squared sine theta dr d theta d1. It is dv, so we can integrate r. The lower limit for the integration of r is 0 and the upper limit is r. And lower limit of integration phi is 0 and the upper limit is 2 pi. And the lower limit of integration theta is 0 and upper limit is pi. So this is the equation. So we can calculate as this and this. So I equals to 4 pi beta r to the power of 6 divided by 9. And the equation, it is written as in terms of its radius r and total mass m 半径と質量で表現しなければいけません。So we need the relation between m and m and beta, m and beta. To have a relation between m and Peter, we need to calculate m. It is integration of dm. So, okay. Not Peter. Peter. Okay. Yes, Peter. Rho is a uniform density, a non-uniform density, and rho is beta r, so we need the relation between beta and n. So rho dv calculated as m equals to pi beta r squared. So we have the equation. So it means beta equals to m divided by r to the power of 4. Okay. And if we have the relation and insert to that beta, 4 pi times that beta times r to the power of 6, about power 6 divided by 9. So the final answer of I equals to 4mr squared divided by 9. It is the answer. Okay. The next one, the last one, 5. A 50 kilogram monkey is connected to a 40 kilogram box of banana by a cord that passes over a pulley. The 20 kilogram pulley is a solid disc. The cord rotates with the pulley without slipping. Without slipping is an important word. The coefficient of friction between the box and ground is 1/2. Determine the acceleration of the system. The system begins from the rest. Is also important. So this is the figure, the monkey hanging here, and the banana box is here. We need to write the FBD free body diagram is needed to solve this problem. Okay, the box of banana, for the box of banana, we can write the FBD diagram here, this. And for the monkey, free body diagram can write as this figure. And for the pulley, we can also write the FBD free body diagram here. T2 is a tension, TR is also tension. Okay. So from this FBD diagram, we can write the Newton's second law equation as this. And also we can write rotation equation. Sigma tau equals to I times alpha. I is the moment of inertia. Okay. So understand this equation from the view of the FBD diagram. Here, here, and the last one is for that, so it means here, okay, and 1/2 mR square. It is a moment of inertia of pulley. Pulley is a solid disk, because the solid disk has the value of the moment of inertia as 1/2 times m times r square. So it is a moment of inertia of the pulley. We can also write the important equation here. It is without slipping means this equation. R alpha equals to AX. So we can solve these equations as n equals to m1g. It is a value of 392 Newton. F is equals to mu n. It is a value of 196 Newton. And insert these values to the equation and calculate the AX value. 295 equals to 100 AX. So the final answer, AX equals to 3.0 meter per second square. It is 295 divided by 100. That is the final answer of the question 5. Right. Okay. Then we back to the 課題。課題は、ここに書いた通りで、いつもの通り3の自己分析した内容を記載して、それを課題として提出してください。それでは